Hello and welcome to the Amazon Web Services Partner Webinar Series. Our topic today will cover managing your SAP disaster recovery solutions on AWS. I'm your host today, Sherry Sullivan. I'm with the Partner Marketing team here in Seattle, and I'd like to start with just a couple housekeeping items before we begin. We'll make today's presentation available post-event. You can find our content available on the AWS SlideShare channel, as well as the AWS YouTube channel. We'd like to remind folks that we are recording today's session, and your lines have been muted. However, we invite you to use the Q&A in your browser at any time during this webcast, and we'll take some time at the close to answer questions. So today I'm very pleased to have with us Patrick Osterhaus, who is the President and CTO of Proterra Technologies, who is an AWS Advanced Consulting Partner. In addition, I have Steve Jones, who is our SAP Solutions Architect with Amazon Web Services. We'll begin today with an overview of SAP disaster recovery on AWS, followed by a deep dive into Proterra's managed SAP disaster recovery solutions that will allow you to increase your operational efficiencies as well as business agility. So we'll wrap up again with a few moments of Q&A at the end of today's webcast. Without further delay, please welcome Steve Jones, SAP Solutions Architect with Amazon Web Services. Take it away, Steve.
All right, Sherry, thank you. So just to kick things off here, I'd like to discuss a little bit about who Amazon Web Services is, what we do. So we're a part of Amazon.com. And I know that most of us at some point have probably used the online Amazon retail store, to buy books, CDs, or gifts and whatnot for friends and family. But there are three main parts to our business. The first is that business, the retail consumer business. The second would be our seller business that will enable retailers to sell through the same world-class online store like Amazon.com. And then finally, there's the Amazon Web Services, which is our IT infrastructure business. What we found with our retail business some time ago is as we grew, we had to figure out how to operate IT systems at massive scale. And we also quickly found out that how beneficial this was to our own business. I thought, well, customers could really leverage this. And so this is the beginnings of Amazon Web Services. So this is a simple view of the set of services that we offer. At the core, we have the compute, storage, and data services that are really at the heart of our offering. And then we surround these offerings with a range of supporting components like management tools, networking services, and application augmentation services. And all of this is hosted within our global data center footprint that allows you to consume services without having to build out your own facilities or equipment. As I mentioned, our data center footprint is global. It spans 5 continents now with highly redundant clusters of data centers in each region. And those are called availability zones. Now our footprint, we continue to expand continuously as we increase capacity, add redundancy in locations, and we do this to meet the needs of our customers all around the world. So just as a point of reference about our scale, in 2003, when Amazon.com was a $5 billion technology-powered retail business, we measured the capacity growth rate of our current AWS environments. We found that every day we add enough server capacity to power all of the 2003 era Amazon business. So as an additional point of comparison, about $5 billion in revenue puts you right around 400 in the Fortune 500. So that means every day we're adding enough capacity to power a fairly big standalone company. Now, some time ago, Amazon sponsored a study by IDC where they interviewed a group of our customers to get a sense of the results they get from using AWS. Now, the results were quite favorable, with the aggregate numbers showing significant cost savings compared with better results in terms of reduced downtime. And we're happy to be delivering both benefits simultaneously, combined with the fact that our customers are able to reduce costs and increase quality of their own environments. I encourage you to take an opportunity to read this report as it's available on our website. Now, you also might have questions about security in the cloud, but our biggest and most conservative customers have found that we're able to meet their security requirements. And often we can provide a better security profile than what they can deliver internally themselves. And our focus and investment in security and the fact that we incorporate requirements from our most security-conscious customers means that this benefits all of our customers on our platform without the additional cost to themselves. We encourage you to dig deeper. We have security white papers on our site, and we're also happy to help get you the information you need to feel confident in our security capabilities. And remember, we run our own businesses on Amazon Web Services, so we definitely take security very seriously. So now that you know a little bit more about Amazon Web Services, I'd like to talk just a little bit about why enterprise customers are choosing the AWS platform. With traditional infrastructure, you have to guess how much capacity you're going to need over the next 3 to 7 years, and typically pay for most or all of it on day one. This ties up money you could be spending on other things like R&D, and it's very difficult, often very difficult to forecast accurately over such a long time period. And with the AWS platform, you pay really for only what you need, when you need it, and you can scale up or down as little or as much as you'd like. The second benefit is that we're offering this infrastructure at a lower total cost. If you think about it, we invest and operate at such a high scale, we pay less per unit than most anybody else in the IT industry. We run our business on a very high volume, low margin business basis, which is also quite unique. So this combination of high scale and low margins allow us to pass significant savings on to our customers. Now, a proof point of this is the 27 price reductions that we've announced over the time since we started. It's really in our DNA to do this, and you'll continue to see us lower prices over time. So our infrastructure follows the pay-per-use model, so it's a lot easier to control your costs internally. It's really important to think about when you consider your own SAP environments. We find that many companies struggle with understanding which levers and dials they can move to control costs in their environments. Typically, a large portion of SAP budget goes to some fixed dollar amount for infrastructure, and no matter how much you remove from your environment, costs still remain relatively high. So many customers are finding that they have direct control over their costs with our platform and can scale their environments to meet demand in a very cost-effective manner. Which brings me to my next point. Sizing exercises in an SAP environment can sometimes be a fairly difficult process. Most of you are familiar with the SAP Quick Sizer and know that you've got to know a lot about which business processes you're going to run in your SAP system, how many users, and then try to accurately forecast growth all at the same time. In the end, you're left with a SAPS rating that you then go and shop around for various bits of hardware. But you're never really quite sure. Did I accurately forecast for growth? What if we need to add additional modules or enhancements sooner than we anticipated? What about month-end or year-end processing? Did I adequately account for that? What about batch processing? So we end up usually padding our estimates quite a bit just for safety, then we go out and purchase hardware. The trick is to have enough capacity while at the same time not over-investing in hardware. Well, there's this annoying fact called reality. And so often we don't get it right. The thing with AWS is you have just-in-time capacity that's always right for your current needs. You've got the ability to add capacity when you need it. And this basically involves just restarting an existing server on a different instance type, a larger instance type, that doesn't require reinstalling or migrating SAP software. Or better yet, you can just add capacity such as more dialog servers on the fly. And even with a little ingenuity, you can automate this so that it's just done automatically. Sizing down capacity works just as well on the AWS platform and is a real bonus because you only end up paying for what you use. You turn servers off, you stop paying. There's a great case study out on our website that we partnered with Proterra called Merrifield, and they actually implemented a scalable SAP environment to meet seasonal demand of their business. So I recommend you go take a look at that when you've got a moment. The other thing we see our customers do is quite amazing, and it has to do with the fact that they're able to reduce the cost of experimentation. And it takes and removes IT from being a roadblock, where each idea costs a lot of time and money. And IT actually then becomes an enabler where you can launch a speculative project very quickly or cheaply. Case in point, we recently had a customer who wanted to explore a new version of SAP Business Objects. They didn't have it in their environment, and they wanted to see if it would help them to support their growing analytic requirements. Now, all of the initial system environment, platform provisioning, software installation, figuring out user administration, those types of things, the whole project was completed in less than 3 weeks. And the bonus? The total AWS infrastructure and systems cost to support this POC was less than $500. So it's an entirely different business model, and companies really can afford to experiment and even fail often. But the end result, though, is that it speeds up this innovation cycle, and customers are able to invent things very quickly and move into providing value for their business. And let's face it, racking and stacking gear in data centers just doesn't really help you win over your competitors. It takes a lot of time and lots of money and becomes a big distraction from activities that can truly differentiate you. Plus, without big economies of scale, these activities simply just cost more. And lastly, since we've invested in facilities around the world, we can offer you a global reach at a moment's notice. It's cost prohibitive to put your own data center together where all of your customers are, but with AWS you get the benefits without having to make the huge investment. In addition, many customers spend millions of dollars in the setup and operation of their own secondary data centers for disaster recovery, or others simply forego the expense and take on significant risk. With AWS, there's a much different option. That's what we're going to talk about today. So while there's talk of private cloud being just as good as public cloud, the big benefits that our customers enjoy just aren't possible with the gear that goes into your own data center, even if it has private cloud attributes. Since you have to buy the equipment up front from high-margin vendors and run it in your own data center that you rent or own, the big costs and operational benefits just aren't possible in the private cloud. So we recognize that it's not an all or nothing, that most customers are going to be on this migration continuum in one area or another. And some enterprises are building new projects entirely on us, applications, even whole lines of businesses. Some enterprises are moving existing workloads from their own data center in a piecemeal fashion, and others augment their IT capacity and they run their own data center with capabilities like disaster recovery on AWS, flexible test and dev environments, and then bursting for spiky workloads. And we recognize, again, that customers' requirements are unique. So we tried to make it easy to implement these hybrid IT architectures where the management and the integration of on-premise and on-cloud infrastructure is easy, and even making workloads easy to migrate back and forth. And these are some of the key products that support this vision of hybrid cloud. I won't get into much of the specifics, but as you can see, the AWS cloud can easily become just an extension of your data center. In fact, many cases, customers leveraging resources on the cloud aren't even able to tell the difference between the application that's running on-premise versus the one that's running on the cloud. And so that brings us to SAP. SAP is one of these workloads that many customers find critical to their business, but also very costly to run. We've worked with SAP over the last 3 years to vet out each of their software products on our platform in order to ensure stability, reliability, and resiliency. As you can see, we've got a complete set of solutions available that customers can run on our platform and still get the same support from SAP that they've come to rely on. And the exciting thing is that customers are adopting AWS for these workloads for all the reasons I've just outlined. And the cost savings I mentioned a little bit earlier, the 70%, there was a similar study done by an independent company called BMSAG, and this company tracks and maintains a very large list of SAP customers and their costs of running their own SAP environments. And their analysis also showed a savings of up to 69% on infrastructure when compared to running SAP on-premise. It's very exciting. So how do you get started? Well, for those that like to read, we've put together a lot of documentation and quick start guides, and they can be found on the website here at this link. I recommend you take an opportunity to take a look at those. In addition, we've really found that customers are more likely to be successful when they include someone with good experience building and operating systems on the AWS platform. Proterra really is one of our go-to partners when customers need help with all things SAP on the AWS platform. And with that, I'd like to introduce Patrick, who will talk a little bit about their company as well as operating DR systems on AWS. Patrick?
Thank you, Stephen. Appreciate the good intro there and the good introduction on AWS. Thank you, everyone, for your time here today. I'm going to spend the next few minutes here. We'll overview the seminar talk here on SAP DR and AWS. And to start with that, we'll give a little brief introduction on Proterra, just so you get a little overview of our skill sets and our history. It is a company that was formed in 1998, 15 years ago, and we have specialized since then in the SAP space. During this time, we've become certified in 4 areas of SAP. So most recently we got the mobile certification. Before that we got cloud. Before that we got hosting, and the first one was AMS, which is application management services. So we started working with AWS for demo systems for our internal systems probably about 4 years ago. And within about 2 years' time after that, we started working with AWS on the certification processes for SAP. So we've been working on the platform for quite a bit, and we're excited to share some of those details and some information, lessons learned from putting DR systems in that today with you. So we have a long history of working with SAP and the cloud solutions that we're going to be talking about. So we want to talk about where the industry's come and many of the solutions that customers have used to run SAP in their data centers. We started here with on-premise data centers, and a lot of companies still run this as a model. They have outsourced data centers as well, where they'll utilize a third party to do the management of the power, networking, possibly the operating system and database, and maybe even SAP in that. We also have some big data center virtualization also happening. Some companies have a mixture of virtualizing with VMware or Zen and putting this into their environments to run the SAP systems. The most exciting part here is merging the newest technologies into the platform of AWS, the Amazon Web Services. And as Stephen mentioned before, the components of cloud are all provided in a platform that is easily procured and managed within the AWS system. So we have the components, as Stephen mentioned before, about the storage and the compute, and the networking is all provided within this one platform. And we're going to go into more details on how that applies to the VR solution in particular, but we'll talk right here about the advantages of the SAP systems. So starting 2 years ago with the certification of the products of SAP, we saw that the advantages of AWS for running in the first system that were available was RDS, which is the ready-to-deploy solutions, and the BOJ systems. Now, in the last few years, we've had 4 new suites added. We have the Business Suite, which is essentially ECC, which most companies will run for their platform for SAP. We also have HANA, which is a lot of excitement around here, and this is a very good way to test drive a solution in HANA, see if it's a good fit for your systems. And it's a good way to prototype and do a proof of concept. And lastly, also we have very important growth area is with the far right and with the mobile space. Getting into the SAP certification. So the portions that are really important for SAP to run their systems on AWS are included here. The foremost thing we should talk about is it's a bring your own license model. So nothing changes within licensing for running a production system in SAP for AWS. The customer still procures the license, and you'll still utilize the operating system and database that you're provisioned for in your licensing agreement. You'll bring that into the AWS platform. Some other key considerations here is you want to look at what systems are certified by SAP. And I know we're getting very specific in some technical names here. You can use the link that Stephen mentioned earlier with the AWS link /SAP. That will provide the actual compute sizes for these instances. When we talk about an instance, we're mentioning the RAM and the CPU, essentially part of the cloud solution. So this is going to specify how many CPUs and how much memory you'll have to run that SAP system. And another exciting point that just was from the last Sapphire and Zaptec announcement was certified the CC2 8X large, which is a very large system, essentially 90,000 SAPs in size. So the largest workloads in SAP are certified to run on this platform. We're going to talk a little bit about non-production scenarios. We're going to go through some slides on that. For those solutions, any of the other sizes, there's many sizes that Amazon AWS provides, and those are okay for those scenarios, and we'll talk through those. The important thing also when we talk about sizing is to keep in consideration the measure for performance that SAP uses for sizing, which is called SAPs, the SAP Performance Measurement Standards. And there's a SAP note which specifies these details, which is listed on the slide. So you can use as reference. So let's talk a little bit about the model of how customers are using AWS currently. This first portion here with the production landscapes is what Steve mentioned. There's a case study I'd encourage you to look at. It's on YouTube and a few other areas on the internet for how you can see a case study of how a company used AWS to provision their production systems. So they captured the advantages of the zero IT footprint. So they brought the systems as they needed, right at the time of when development was starting and functional teams got into SAP systems. They didn't have the software and hardware provision for months before and had to worry about buying the hardware 5 years and annualizing that over the payment for those 5 years. It's, as Stephen mentioned, if you pay as you use it. So they built these systems, and the other big benefit here is that seasonal demand, where their seasons of about 40% of their business is done in a couple months. They can ramp up resources and decommission those as needed. So there's a webinar and a case study specifically on this I encourage you to look at, which gives more details on that. The company name is Merrifield Garden Systems. Is a good example of this first bullet. The second bullet is hybrid, and the easiest way to think of this term is the combination of cloud with on-premise. And when we use the term on-premise, we mean essentially the customer's system, be it in a third-party data center or in their corporate network. This hybrid is going to be, I think, a big area of adoption for how companies utilize cloud. They're going to be looking at how to connect their current on-premise systems into the cloud and what considerations specifically in SAP do they have to consider. And again, we have a webinar just on this area, the considerations including the transport management system. How do you interface systems together? How do you do printing, right? So all these considerations that you have in a on-premise solution, how do you extend that now into the cloud? And that's considered. And I think this is a good place where companies can start. They can put a sandbox system for ECC or CRM. They can put it into the cloud, and they can see, as making a copy of their dev system, they can put it there and see how it acts and learn how to administer the system is a good proof of concept. Another key area that we see much growth and a key acceptance of AWS for SAP is the Cloud Appliance Factory. So the Dev Lab on demand, essentially how we can create very quick sandbox and proof of concept systems. These can be available, within a moment's notice. So one of the key advantages of AWS is how quickly you can provision a system, and it's literally in minutes. So instead of having to procure hardware, add memory to be able to build a system, you literally can go into the console, and within a minute you can click on, I want an operating system Windows 2008 and with this database, and within minutes it's created for an instance, and you can start installing SAP. SAP has taken that a step further, and they've included an area called the Cloud Appliance Library, which you can actually get pre-configured images that you can have SAP running on top of that operating system and that database stack. So they're already taking a step further where you can already have a pre-configured system. So you can sort of see where this is going in the industry. Instead of getting a stack of DVDs, you're just going to go out and get an image off the cloud and do an installation. And that's already in place. And lastly, the subject we're going to talk about today is the cloud-based DR. You may also hear the term RAAS, which is Recovery as a Service. This is a big area of future growth that Gartner's recommending and predicting this is going to be a big area in the next 5 years of tremendous growth. And we see this already, a lot of excitement with our customers and internally in our company of how much this has improved operations for companies for doing DR. And there's some inherent advantages in AWS in the platform that apply itself very well to DR, which we're going to go through. So before we get to that and how AWS does it better, we're going to look at the typical concerns. This would be, 10 years ago, if you went and asked a company, what's your concerns about DR? These are going to be some of the questions you're going to look at. These are the questions that when we were doing on-premise DR for companies, what we would always try to get answered and make sure that the customer had full understanding of the solution and the timeline that it would take to implement the solution fully. So we'll go with this in detail, but from a high level, we got the geography of the systems. We got the RPO and RTO, which is essentially how much time and how much data is lost if a DR event does occur. And we also are considering the sizing of those DR systems. How big should we make those systems that are going to be failed over to? Are they going to be sized identically to DR, or are they going to be a fraction of the size? One of the biggest parts, I think, in design that is where people spend the most time with the solution is in the connectivity and the synchronization. It's essentially how does this solution work? So we'll talk through that in detail, and then also the testing of systems, which DR is only as good as the test and how much it looks like production, and how can you utilize that DR system once a DR event happens. So we got to give considerate thought on how a company is going to access and utilize that system after an event occurs. So we'll go through all these 5 points here in detail. So as Stephen mentioned, he talked about the regions in the AWS around the globe. So the zones here that we were talking about in Europe and the United States and Asia Pacific, I'll talk to areas that there's multiple data centers in the region where you could have a DR system and you could have it synchronized from a production system. One of the things that we typically get as a recommendation or as a preference from our customers is that they like to have DR in the same country, not in a very close proximity of where the production system is located, but they want to have it in the same country for a lot of regulations and law requirements. So that can be complied, with the regions for AWS, which I think Stephen mentioned there's over 20 now, nearly 30 locations that AWS provides. And within a region, that's a very important term where we can look at the multiple data centers within that region, and there's recovery within the solution of regions, that there's data that's replicated within the region itself. So not only are we talking about the replication of data from production into the AWS solution, but the AWS solution itself, where DR is located, is replicated also. So there's protection upon the protection of just the separation of geography. It's a key point. So, and I also should mention the security regulations and the compliance that AWS has within all their data centers, and they have some data centers that have even higher restrictions for government and defense, Department of Defense clearances. So the topics here about RPO and RTO. So just simply said, the RPO is the recovery point, how much data loss can occur, and the RTO, the recovery time, is essentially how long we're going to take that system, that DR system, to get back up and users can start utilizing it again. So the biggest area that affects RPO is how the synchronization is done. And within AWS, there's a lot of tools, a lot of methodology that can be applied. The first preference we have working with the customer is, if they have another tool that they've already utilized for DR, or they have some expertise in that, they would bring to bear again. If the customer does not have something already, we would recommend our own solution that we can build utilizing standard tools that the database would utilize. It's an important part here talking about the synchronization part. We talk a little bit about that later, but the key part is about the synchronization. And there's multiple ways this can be done even without a third-party tool. So the important thing is with SAP, we're not just talking about just the database being replicated, but we need to have the whole environment. That includes the file systems, if it's a Linux system or the drives of a Windows box, that's going to be replicated also. So that's paramount for all the pieces. That's going to be synchronized. But the driver for RPO is the tool, how the synchronization is done, and how close can we get that for, to get that for data. The RTO, again, similar requirements on the tool, which will drive RTO. The other part that's going to have a big part to this is how long it's going to take for the company to change their processes, to reconnect to this new location. And there's some ways that we can optimize this utilizing the network and some reconfiguration of the corporate or the on-premise networking equipment and how they're going to access the DR site. There's some changes and some improvements we can recommend to the team, but this is tightly integrated with how business is done and how the DR processes are set up to access the system. Our standard SLA, which is aggressive as our standard for AWS, is a 4-hour RPO and a 2-hour RTO. So this is an area that it's going to really benefit to having a discussion with the customer what currently they have, if they have a DR system in place, and if not, we can recommend some ways that we can try to the 4-hour RTO, or 4-hour RPO and 2-hour RTO. Getting into the topic here on sizing. So the sizing of SAP systems, as we mentioned before, there's a newly certified size instance, the CC2.8x large, which can drive large SAP systems. Our standard, which we drive for SAP systems and DR, is with the M2 4x large. So it's a good size system. That would be for the database server, and then we can scale that horizontally where we add additional app servers to that. So quite large SAP systems can be put into the DR scenario. And the way we also do this with sizing it is we would, as Stephen mentioned before, where we can scale this instance up and down, we can actually use a smaller system. So you don't have to have a system that's always in recovery mode and sync mode the same size of the production system that would be in the DR, when a DR is declared or a DR test is initiated. So it's a key point. So the cost for having a system in DR mode and recovery mode is going to be significantly less because you're not driving the same resources that you're going to be using in a test or a DR event. So how we actually size it is really dependent upon the business. We have recommendations. Typically, we're going to have the test system sized 100% of production. We have instances where we actually have the DR system sized even larger than that because we can add scale and add the instances very quickly in AWS. So it's customer dependent. There's a lot of flexibility. Getting to this very important topic I mentioned before, this is probably the area that companies spend the most time designing this and how they want to connect. Obviously, how they are architected already, how they connect their sites into their current SAP systems is going to be a key driver here. One of the key benefits I think that I've seen with AWS is the fact that we can utilize what's called VPC, the Virtual Private Cloud connection here, that you can utilize for connections from a data center. So essentially, you can utilize a VPN site-to-site, for example, to connect to virtual private cloud. And within the virtual private cloud is a suite of tools. So you're going to have essentially the ability to create the VLANs, create firewalls, to create public IPs and NATs. So essentially, you can create the most complex solution that you're going to have in a physical on-premise solution where you have a DMZ, you're going to have a load balancer. All these things, all these concepts can be fully realized in VPC. So it's a key part, and actually that's a requirement to run SAP on AWS is the VPC portion. So you would architect utilizing this network, and then how you're going to connect to that, you have many avenues. So you can do a direct connect, a circuit from your data center into the AWS data centers, or like I said, you could do even a site-to-site. Our standard, what we start with is we recommend companies to use a site-to-site, and depending upon the connectivity and how much bandwidth is driven between their on-premise solution and the AWS data centers, we can architect it if they need something aside from the site-to-site. But by and large, our standard for testing and even for production, we've been able to utilize the site-to-sites by and large. And the other important part here on synchronization is I mentioned the third parties. So the third-party tools we can again utilize and sit on top of the platform that AWS provides with the network connectivity. So key parts there with the connectivity is to start with VPC and look at how we can leverage what's currently existing for the on-premise solution. We had one of the solutions that we mentioned in the case study previously, they were able to replace all their previous MPLS circuits within the VPC and utilizing site-to-sites. And they actually had improvements increase, and outages actually were less than the MPLS circuit that they had previously. So the cost was tremendously less. So something I encourage to look at, and it's a key benefit for the AWS platform outside of DR, just in general. It's a key benefit. So the important part, aside from the connectivity, is then the testing. And it's how do we actually look at the system once it's built, what are we going to look at? So we have the data synchronization, I should say the process of this is what we'll detail, and then we'll go through the actual testing here. But the actual process of how we test the systems is we have the production system obviously is always up and is always creating feedback, the logs, the transaction logs that are going to be sent over to this disaster recovery system. So we always have transaction logs that are being sent from the database platform. The other thing that we also have to consider is the synchronization within the operating system. And there's numerous ways, third-party products and even inherent operating system tools that we can utilize for that synchronization. But we want to quiesce those synchronizations for a period of time. Once we do that, we actually utilize the inherent features in AWS where we can copy systems. And the system, we can do a snapshot. We can create a new instance from that. And when we do the testing, we're not ever affecting the base system that is in recovery. We quiesce the application of logs and the synchronization for a few minutes. We create the copy, and then we restart the synchronization. So this is another key benefit of the DR solution in AWS is that we don't put the DR solution at risk when we do testing. It's not a matter that we're going to bring up the test, or the system that's synchronized, bring it up for a test, and then we have to recreate DR again. We're always having a DR recovery system in place. So if a DR event occurred while we were doing a test, you wouldn't have to worry about data loss. You're not worrying about the test being 2 weeks old and you're using that system now. So it's a key benefit. and it's native in the AWS solution without any other third-party products. Once we have that copy of the DR system, then we actually can do the testing. So we look at the DR system, we're going to start it up, and if you took an operating system or a basis SAP system administrator and put them on the AWS platform, as Steve mentioned, it's going to be analogous to, they wouldn't know if the system's on-premise or if it's in AWS. So they go into the operating system, start SAP, and they're going to do essentially just like every other startup procedure. If they have other interfaces, they have other systems that have to be started, they would be resumed then at that time. So a key part we're going to look at also is the interfaces. We got to make sure that these products are started, and if they're going back to another data center or a third party, we have to make sure those network connections are working. So this is an area that we spend the most time on. It's actually building the DR system is not the most effort. It's this portion here with the testing the system is where we'll actually spend the most time. The actual building will take us, in some scenarios, the case study we have here I'll talk about was days. The actual testing and building this up, this could take weeks, to get the customer confident with that the full solution is being tested, and it's all located in the DR location. Okay, so let's talk a little bit about the process and how do we build these systems. Stephen had a slide he mentioned before, which is a key part, and you might want to do a replay on this and go back to it was at the beginning about the components. We talked about VPC, we talked about the instances. The other key part here that is utilized for DR to build systems, not only for DR, but if you want to do a copy system, is the VM import, so that you can do an import-export. So to get the data into AWS, there's many mechanisms. It can be as simple as copying the data into a USB device, and you can import it into the instance in AWS. So this is one method you can use to build a system, and I use this as an example here. So simply said, and this is going to be a similar way that we're going to utilize for the instance for production, we're going to make a copy. And what we recommend is we actually do a database online backup. So there is no intrusion within the production environment of interruption of the system going down. So we have the online backup, we snap at a point in time, and we're also going to send the logs also, right? And we're also going to take a synchronization, depending upon the method that we're going to use for synchronization of the operating system, we will do that right then. But the key point is we don't want to bring production down. So the customer would not even know a DR system snapshot creation is being done. We take all that data, we put it into the NAS device, and we copy this over, we send it over in FedEx or UPS into a location depending upon what data center you use in AWS. Within a day's time, that data is all imported into AWS, and we attach it into the instance. And then at that point is essentially the process to building a system, a copy system, is much like you would do on an on-premise. So you're literally just copying data from one server to another. The difference here is that those data centers are in different regions. So, and the other key part which we recommend companies to build concurrently is that connectivity. Because as people know, if you're going to use a circuit, there's lead times of some companies will have, usually it'll be 30 days, but we've seen companies, if it's international, could be up to 90 days to get a circuit between a site. Again, we recommend try to use the VPC, which is required, and try to site to site. Usually companies can spin a site to site up much faster than a circuit, and we can use that and test utilization on the pipe. You can see latency and any issues if a dedicated circuit's even required. So we got the system built, we did the testing. One other thing that companies are going to want to test is how can they return a system that's in AWS for DR? How can they return that back into the on-premise location? And simply said, we're going to essentially do what we just described for building a system in AWS. We're going to reverse it, right? But the key part that I should mention here is the conversation the customer should look at is, are they going to even keep the system on-premise? There might be a driver just to keep all the systems that are DR in AWS. There's no reason that they couldn't run there, and that's the company's DR testing can provide the metrics and ensure that they have a full solution they could just leave in AWS. So it's not a key given that we're going to return the AWS DR system back to the primary location. So that's a key consideration that I'd recommend that you look at. The steps here, like I said, is to go back. We're going to copy the DR system. Again, when we do an online backup, we utilize the export procedure here, and we can build a system then on-premise. So again, the synchronization. So if it's done right, there will be essentially just minutes outage when the synchronization is brought up on the new prod system in the on-premise location. So let's summarize those key parts here in these areas. So the big parts, the comparison on AWS versus the traditional DR is the fast deployment. So again, we can create these systems in minutes. Once you have the image, you can build out something in Red Hat, Linux, for example, put SAP ECC6L, and then you can use that as your base for all future builds. And again, the fast deployment, utilizing a system copy between data centers, worst case would take a day to get that NAS device copied from, if it's going across the country, and imported. But they can be copied within the AWS cloud very quickly. And there's connectivity options within the AWS data centers that can utilize, so you can copy from one region to another. So that's another option you can look at, where you could move from the west region over to the east region and move the systems over the AWS cloud for multiple locations for DR. The simplification of DR testing, again, the systems can be kept in sync. So you always have that system in recovery. You never risk that system at any point, even when a test is being done. And the other key benefit is you can utilize multiple test systems. So you can have a group that's testing their interfaces. You could have another group, the HR group, for example, wants to test some key functionality in their area in the DR. They could request a new snap to be done if the interface testing has been out there for a month and they want the HR team wants new data. So they can create numerous copies very, very easily. And this second bullet actually brings up a whole other subject, which I think is exciting for companies to even entertain, is that this area that you can do a DR copy is an easy way you can do a copy of production. So a lot of companies could even get rid of their prod copy system that they have on premise, and they could utilize the prod copy that they now have in AWS. So another key benefit here, is another side benefit of doing DR in AWS, is that you can get very quickly a snapshot of production at any moment. I think that in itself will be a key feature of doing this, the synchronization in AWS. Again, the traditional way of doing networking, where you're going to have expensive circuits as a requirement to interconnect companies and locations. Now you can look at the new way, the improved way of AWS providing networking, and that's utilizing their enormous carriers, the various carriers they have for each data center, and the options with VPC. So again, we have multiple companies that have got rid of their MPLS circuits and replaced them with the VPC VPN site-to-sites. Stephen mentioned the multiple zones, the multi-zones, the resilience of the environment. It's replicated within the zone, so we're talking about replication of the data itself and the massive amounts of data computing. So if an instance would fail for some reason, you had a hardware fail, it's very easy to just restart the instance on another physical instance. And the last thing is stability. And Stephen showed that excellent slide, I think it was the third slide in, where it shows the evolution of AWS came from the Amazon.com platform. So I think they're probably Amazon's one of the very few companies doing cloud, for almost 20 years now. They've been leading this charge of how to do cloud computing, and you can leverage that, the experience and the knowledge they've gained over all the years, and put that to your SAP platform. One of the last key points here I wanted to talk through, or let me do the deployment scenario. I'm sorry. The deployment scenarios to talk about essentially who can connect or what environments can connect to AWS. This is a question we get quite a bit. Is essentially we see all types. We see other clouds, other providers' clouds connecting to AWS to provide the DR solution or even the hybrid solution for SAP. We also see the most popular, the corporate on-premise, where we see companies looking at the hybrid model. They want to connect some of their on-premise systems to systems they have now in cloud. And also we're data center. So the data center maybe for a third party that they connect their systems to AWS. So we've seen all the deployment scenarios. We have multiple systems running for each scenario, and obviously the connectivity might be different and some options there, looking through, but essentially all kind of environments can connect to the cloud. So summarize here on the DR, the testing. These are key benefits, that just the top bullets here. So we recommend the DR test periodically with the key business processes and see a lot of levels of how complex and how detailed these processes can be for companies. Some of them they'll actually have a formal test, a week, once a year, that they'll actually test through all the business processes to go through the DR. The nice benefit, again, is that they can do this 3 or 4 times a year now, where as before in the previous provider, they could only do once. Economically would restrict them. The interface testing is customer specific. The amount of interfaces varies by customer, but it's a key area to make sure all these are working. And this brings in, with the next subject of printing, the importance that we make sure that, like a copy production system, that we're not printing and we're not sending out real documents, because this is a copy of production. So we want to be concerned with how they're networked and restricted, making sure that they don't go back to productive printers or productive faxes to the customer. And lastly, third-party products, which we know there's a lot of third-party products in any customer environment for SAP. We want to make sure that we give a good legwork out to all those products, making sure they work, the connections work, and they're all installed properly in the DR location. So lastly, before we get into our case study, wanted to just talk about the SLA agreements. And the key part here, it's not so much the details, but the point being is that our company, Proterra, stands by SLAs for SAP systems on AWS. We have the confidence, and SAP has certified the product very robustly a few years ago, and continue to, as new products come out, they get certified for AWS. The research and the due diligence has been done on the platform. So we are willing to put contracts that there's penalties if the system is down for whatever reason. We put SLA agreements on it. So again, all these areas are going to be in the SLA for the performance, for the resources, the connectivity. All these pieces are vitally important, and we stand by it with production systems. So let's talk about an example here of one of our DR companies that we put into AWS, and the company is Galata Chemicals. They're located in Southbury, Connecticut, as their headquarters. They have plants in both the United States and in Germany, and they're a spinoff of a conglomerate chemical company which occurred in 2010. So what's really interesting about their platform is they literally have every piece of ECC implemented. So they have hundreds of add-ons that they put into that had to get spun off of the system and put into this new company that was created in 2010. So it's, for a DR scenario, a lot of complexity of putting all these pieces into another environment. The key benefit here for the company specifically with AWS is the speed at how quickly we were able to build a DR. The traditional environment before was a week, multiple weeks to build the system every time they want to do an annual test. Now they have the capability to do a test every quarter. It's really how often the business drives it. And as I mentioned before, they utilize this also to do a prod copy. That's another side benefit to it. So again, the SLAs for uptime, the RTO and RPO, which we talked about, key benefits where they can get the systems up very quickly and built. So let's talk a little bit about their environment here. So we got ECC, just a sampling of modules. It's on Oracle, on Red Hat Linux. They have over 300 users around the world. So they have plants in Europe and in the United States. They have users essentially around the world, but they have Asia Pacific users also. And their solution, the full solution is in the cloud. So they have not only DR, but their production systems in the cloud also. Their locations that they have all their employees located at are connected through MPLS connections. So the data center they connect to is all MPLS for production. And again, in Germany and 2 locations in the United States are connected through various T1s, multiple T1s, or in Europe it's an E1 for connectivity. For the DR system, what's utilized is all VPN. So the network to the data center and to the corporate network for Galata is all connected through VPC. VPN, like the site to the Amazon VPC. So you can see a brief summary of a very high level of how it's architected, where we have the isolated, the DR failover site. I mentioned about the regions in the sites within a region where we have data replicated. We take advantage of that, where we can take snapshots of the DR system and then it's replicated into another data center. So again, key takeaway here is that the speed to build it, the ability to do a test at any time, and the cost for those connections, which we summarize here in these benefits. So the other impressive stat there is that it was measured 70% reduction in the cost of operating a similar solution in a traditional data center, which Stephen had a slide there at the beginning that talked about the companies. There's two independent companies that did studies on running AWS for the infrastructure and then running AWS for SAP. So key, very important white papers you can review to see the key benefits for the cost. And with that, we end the slides here we were going to present. We have some additional links here. You can learn more about the services. And as Sherry mentioned, we're going to be posting this on YouTube and also SlideShare, so you can get the slide deck and also the interactive portion of this webinar. And so you can go back to these links if you don't have time to write those. The key link here for AWS is this first link. It has basically links for everything else in this TCO study, which we just mentioned. And with that, we can go to some questions. I know we have, it looks like 7 minutes left, and we have lots of questions coming through, so we can start going through those. And we can start here. And Steve, I guess we can, I'll start reading them off, and then we can look at, if you want to pick them up, or I can. So we can look at the first question here. Does AWS have a standing metric or SLA for recovery point objective? So I can take that from the standpoint of DR specifically. The SLA is provided by Proterra, so we consider all the SLAs that's in the AWS product, and we work with the customer on the recovery point and recovery time and the performance. We work with the customer specifically in those areas. So those are, it's customer specific, let's say that way. That would be through Proterra, not AWS.
And there's a question here around network availability. So for high availability of network, do you have numerous carriers coming into your data centers? So yes, we have numerous providers coming to each data center for redundancy. In addition, in separate availability zones within a single region, where possible, we also bring in additional carriers. So we recognize that network is of vital importance for being able to get access to these resources. And so redundancy is important there. There's a question here on where is GovCloud location in the U.S. Did you take that one, Steve? Did you answer that better myself? I did. That's on the West Coast. We did that for a number of reasons. Many governmental agencies actually run a lot of workloads out of the U.S. East region, and they wanted another region on the other side of the country for disaster recovery purposes. And we do expect or plan to expand out the GovCloud region. Excellent. One of the questions we commonly get, I see someone ask this, is what platforms can run in AWS? It's an excellent question. Right now, x86 essentially. So obviously we support what SAP supports, so you got to look at the SAP supported operating system database, and then we look at specifically what's x86. And that question can be extended also to the third-party products. So third-party products that support x86 and the industry is going there, that's the answer. The other key question off that, the corollary is, if I'm running Unix now, how can I get to AWS? And it's companies are looking at doing migrations essentially. If they look at Windows or getting to a Linux platform that enables all these very cool features of DR and hybrid cloud into AWS. So I know a lot of companies are looking at that. There's a question here around the difference between a region and an availability zone. So if you remember on the geographic slide, we have regions all over the globe, and a region is basically, you can think of them as separate clouds. So data doesn't leave that region unless you specifically move it yourself. AWS won't move that region, that data for you. Availability zone, or you can think of that as a data center or multiple data centers within a single region, and they're all connected by a very high-speed fiber network latency between those is very minimal. So you get this idea of architecting applications across availability zones within a particular region for high availability, and then leveraging additional regions for disaster recovery.
Very good. One question just came in: how long did the case study for Galata take from the inception to completion? So from the time we talked to the customer to design it, it was completion about 6 weeks from the time that we designed the solution, architected networking, got the systems built out, and did the testing. In the testing, it wasn't completed at that first version. We continue to refine the tests, what they learn, and especially as the system continues to get new functionality. They add new modules, add new data, new people. That we continue to add to that testing. So 6 weeks though, from the beginning to the first DR test completion.
We probably have time for one more question. Pat, do you want to take this, and then Steve, maybe you join in? The question is, what are the backhaul traffic requirements for on-demand DR system using AWS?
Mm-hmm. Yeah, I could start that, and Steve, please add to it. I think that the big driver there is looking at the solution from the customer. So how many SAPs is probably the big key driver of the prod system, or prod systems, I should say, for that solution that the customer has. So looking at how many SAPs and then driving the traffic. So it could be tremendous. But, we could have, you might require a pipe that's going to be 5 megabits or 10 megabits continuous load. So we have to look at that, and also the latency. So I think it's not to provide a great answer, but we need more information to see how the system's sized, and we look at the SAPs to do that, and then also the location of the on-premise location in what AWS data center you're going to. But we've done some very large systems in AWS, and I encourage you could follow up with us, and we can get into more details for the customer specifically.
Yeah, no, Patrick mentioned, depending on the requirements, how much data you're pushing over the pipe, you can use the direct connect option with either 1 gig or 10 gig links, or multiples of those. So I think there's enough options to get you the capacity you need to fit the traffic requirements, depending on what that is.
Well, we've covered a lot of ground today, so on behalf of AWS, I'd like to thank Patrick Osterhaus with Proterra Technologies for joining us today, and Steve Jones with AWS. We'd like to thank you for spending an hour with us. I've seen some great questions come in. We will follow up with you folks offline directly with your questions, so please feel free to submit them as time allows here. And before we let you go, I'd like to just again thank you for joining us. We looked for ways to improve our webinar series. Please take a very short survey, give us some feedback, and join us again at a future session. We thank you for your time today.